welcome back. Now in this video, we are going to see how we can find a required sample size. It's not all the case that you will be finding the margin error, no. There are some questions that you can be asked to find the sample size. Which sample size? Let's see. So given an E, that means that the margin error will be given to you. You can find a sample size needed to get that E. So I can do the job for you by giving you the E, then task you that find me the sample size needed to get that margin error. So then let's see how we can come out with the relation of the N. Good. So it's just small algebra that we are going to do. We are just going to see how we can make this N the subject. That is. Let's go. So having something like this, what is the first thing to do, please? I'm not sure you are telling me I should square both sides for now. That one will work though, but with something else. So we can choose to divide everything here by Z alpha over 2. Z alpha over 2. Or we can say that. So you get E over Z alpha over 2 being equal to this will cancel this, right? P hat, Q hat, all these over what? N. Bear in mind that the square root is affecting the N too. Alright, so when you get to this side, you can see we can square both sides, right? In order to be able to remove the what? To remove the root here. Good. So from here, we can get E squared over the Z alpha over 2 all squared being equal to, this will take away the root. So we are going to get P hat and the Q hat. All these over what? N. Alright, so we want to make N the subject, or we want N to stand alone. So just multiply this by this, that's cross multiplication. And we are going to get N E squared is equal to Z alpha over 2 all squared P hat and Q hat. Okay, so now after getting this, we want to get our N. So what will you do? Divide both sides by what? E squared. So we divide here by what? E squared. Here by what? E squared. Beautiful. Therefore, our N is going to be derived as Z alpha over 2 all squared. P hat, Q hat, all these over E squared. Go! So this is going to be the formula for finding the sample size needed to get a margin error. Alright, so it's not something that you have to choose because you know how to go about this. So please, you can choose how to choose it. Depend on you. Alright, let's see. So, but let me tell you something. You say that there are some questions that you will not be given the P hat. So how can you get the Q hat? There are some questions that, the sample proportion of the population will not be given to you. So when it's not given to you, you specify it. So you will choose to be 50-50, right? So that means that then my assurance will be, let's say, 50-50, alright? So that will be 0.50. Then the Q hat will be 1 minus this. That will be 0.50. So when it's not given, this and this is going to be 0.50. So that is going to give you Z alpha over 2 all squared. Then see something. You are going to multiply this by this, right? So let's take a calculator and do it before we fix it into the formula. 0.50 times 0.50. Yes, I knew already it's going to be 0.25, so I don't want to confuse myself. 0.25, alright? And all this is going to be over E squared. So this is another way to rewrite this, okay? So if you don't know anything about the sample proportion of the population, then you use this formula to get the sample size. All right, I'll be back with the question and you will have it. Trust me. All right, welcome. Nice question. In fact, as I said, if you learn maths and you can't use it to solve a real life problem, then there is something wrong somewhere. All right, so let's look at this question. We want to determine the percentage of UEW, University of Education Winneba, UEW students who have internet in their local areas. Who have internet in their local areas using 95% confidence level. What does, or I should make it 99%. Let's make it 95, okay? Using 95% confidence level, what does the sample size needed to be ensured a margin of error of 4%? I. Okay, before I come to the I, so now let's first look at what we are given in this question. So, looking at this question per se, you can see that first of all we are looking for something, but we will come back to that later. But you know the confidence level we have, and also we have been given the margin of error, and that margin of error is what? 4%. Beautiful. Alright. So, what are we to find? 16.9% of people use internet in 1997. In 1997. So, we are going to use this to find or to determine the percentage of the UEW students who have internet in their local areas. Good. So from this question, this maths, let's see what we have and so on. What is N? That's what we are looking for. So don't forget the question. It says, what does the sample size needed to be ensured? Alright, so that's what we're looking for. Now, another question is that, were we giving the p hats? Were we giving the p hats? Beautiful question. So, in this question, it's not the same as what we solved in the previous one. Because here, it's not about trust. It's not about trying something or whatever. They are going to say successful trial by the number of sample size. In fact, in the first place, you are looking for N. You don't even know the N. So that means that, let's see, we know that this is what? The sample proportion of the what? Of the population of the Sussex. And we know that the Sussex is 16.9% of people use internet in 1995. Sorry, 1997. So that becomes the success. So that means that the sample proportion of the population success is going to be equal to 16.9. Alright, then we can now determine our Q hat, which is 1 minus 16.9. And that's going to give us, oh, sorry, give us population 1.69. 1.69. So sorry, here is rather 0.69 because population can be more than 1. We know this, population can be more than 1. So there is a mistake there. It's 0.1 is 0.169. So we know the population is 0.169. Yeah. That means 1 minus 0.169 is going to be 0.831. Good. So because that is the people who use, so that is the suffix. So you can't say that is for this. No, that is for this. Alright. So if let's say people who do not, then that will go for the kill hat. So that 1 minus that will give you the what? The PR. It's not only that the PR will be given to you. The failure can also be given. Alright, you know this already. So now let's go for what is left again. Good. So we need to go for Z alpha over what? 2. So first of all, we know that alpha is equal to 1 minus the A, right? And what is the A? Here is 95%, which is the same as, so that 95 is the same as 0.95. So that is the A. So to get the alpha is 1 minus 0.95. And this is going to give you 0.05. That we know already. Good. So you are going to use this to draw your normal distribution curve. Alright. So we have already done this already. This is a common one. So let's go alpha over 2. I have taught you how to read it also. So don't worry for this. Good. So here is going to be the 1.9, so negative 1.96, 1.96. Good. So here is going to be the 95% confidence sure. Then the area here is going to be the alpha over 2, which is, so this, when you divide it by 2, you get 0.025. What previous video was it? Here will be 0.025. Alright, so that's that. So after getting this, then we can now move on in finding our what? Our n. Because we know our Z alpha over 2 to be 1.96. Good. So we can clean this. Alright, so now let's go. So we know that our n from what we derived is equal to Z alpha over 2 all squared. P hat, Q hat, all this over E squared, right? So just substitution we are going to do. So Z alpha over 2 is 1.69 all squared, multiplying 0.169. Then the Q had to be 0.831. Good. All this over. We forgot to identify this. Sorry, I'm very sorry. So in the question we were given the E, and that E is the 4%. But here you have to convert it to decimal so that it will help you in your calculation. Don't maintain it because we are dealing with proportion here. So don't maintain it to be what? To be the 4%. To be in percentage. No. So 4% or 0 points. So that would be sorry. So that would be 0.04 because it's just 4 divided by 100. So 0.04. So that's going to be your error giving you. So that would be 0.04 all squared. Alright. Then just punch on the calculator straight away. In all, you are going to get 337.11. You are not yet done. Please wait. You know that the n here is representing what? Number of what? Sample of what? People. So it's representing number of people. So it's representing the number of people there. Then it can be in decimal place. So here, what we do in probability is that always we run up. So with this, you have to run it up to 338. So that will be for your n. Alright. So the next question is that under the same thing, assume we don't know nothing about the internet usage. We are going to assume we don't know nothing about the internet usage. So if we don't know nothing about the internet usage, then that means that, so please let me interpret this one well for you. So that means that that's 0.169% of people use the internet in 1985. So the end here is saying that at 1985 there is a number of 338 UW students who use the internet. That was clear. Alright, so now this portion is saying that assume we don't know nothing about the internet usage. So that means that here we cannot get, it's like the P hat and the Q hat is unknown. Just like that, it's unknown. Because we don't know the success and we don't know the failure. So we can be in 50-50 and say that then the Q hat will be 0.50 and the P hat will be 0.50. Alright, so when you don't know these two, that is when your formula for the n. So we want to get the number of people. Assuming we don't know. So z alpha over 2 all squared. Then you see Q times this, so you get 0.25 here. You know it already. Then you have 0.04 all squared. Right. So the result is going to be 600.25. And we always round it up. And when you round up 0.09 number of people who use the internet. Thank you. See you for the next question. Wait, let me add some things to you. Let me add some things to you. I love you, and I always want you to know more, alright? Good, let me go to this. How we are done writing this? Now, let's say that this type of question normally appear in objectives and all that. Given a critical interval to find P hat and E. So we know this already. Alright, we know this already, right? So in getting the P hat is going to be equal to, it's just something that I want you to know, plus the error. Sorry. Upper plus the lower. All these over 2. Then the E, what is the margin error to be the upper minus the what? The lower. upper minus the what? The lower over 2. Alright, so just these two things I want you to know. Okay, so the upper will be this side. Okay, the upper will be this side, and the lower will be this side. Okay, your operation here is the upper, and your operation here is the what? Is the lower. So let's look at something like this. Let's look at 95% confidence interval of 0.5, 8 less than B, less than 0.81. I forgot to add you this. You can be asked that. Okay, I'll give it to you as an assignment. Alright, so now you can see the upper and the lower. Alright, so for you to find the p-hat, that's the sample proportion of the population of the Sussex. So the p-hat is just the upper plus the lower. So the upper plus the lower over 2. Then you go your way. How you can see that? To get the E is the upper minus the lower. So 0. Minus 0.58. All this over 2. So this will give you 0.695. And this one will give you 0.115. So that is how we go through such one question. Alright, let me give you a question to go and try. Allow me, and I always want you to work also. Alright? So let me pause the video, I'll be back. Alright, so you have to go and try this question. In a study of 1,300 randomly selected models, 900 of that were dropped. 900 of that were dropped. So we have 1,300 were randomly selected model. 900 of that were what? Dropped. So even though we select 1,300, but 900 were what? Dropped. You have to know what it means. Find the best point estimate for the proportion. Please, don't be confused with this. You know the point estimate. I'm not going to solve it with just a tip. The point estimate is the p-hat. So this part is just asking you the p-hat, which is s over what? N. And you know it already. What will be the n? What will be the x? Know it. You have to know it. Alright. So when you do that, okay, so when you do that, you're going to get 0.692, 0.6923. Alright, let's go to the second one. Confidence of 99% confidence what? Interval. That is when you'll be going for the what? For the intervals. That's the confidence interval. That's when you'll be using this. You choose your alpha. So here is 99. So you have to know what your alpha will be. Alright, so you use that to get your interval. And when you do that, your interval will be 0.6593 less than P less than 0.7253. Alright, so this is going to be your interval. The next question is, are most cases dropped? This is where I want to help you with. That's why I was just giving you the tips. Are most cases dropped? Looking at the interval, you see, here is 0.7, here is 0.6. So are most cases dropped? Yes, most cases were dropped. Simply that, and you are done. So here is yes. Yes, most cases were dropped. Then you support your claim. Alright. Thank you. See you for another video. And you will have it. That is confidence interval for the sample mean population. See you.